Hello everyone and welcome to another problem solving video here on Scode. Today we're going to talk about the math evaluator problem from codewars.com. I know that we normally get most of our challenges from leetcode.com, but I decided to go to Code Wars for the next few problems that we'll be doing. Code Wars is a very good, very competitive programming website that presents challenges to many of the programmers that you go and you create a profile. You can join what they call a clan, which is just another group of developers, and you can level up. So you can sort of continue to do problems and improve your levels, so to speak. Their level system is a little peculiar. It starts off at a level 8Q. I believe I'm pronouncing that correctly. I may be pronunciating it wrong, but you start off at a level 8 and you can ascend, or I guess descend, depends on how you view it or how you look at it, all the way to a level 1. Most of their problems are sort of scored the same way. So a 8Q problem is not a very difficult one at all, and the highest difficulty problems are a level 1. This math evaluator problem that we're going to discuss in this video is a 2Q, so it's a very hard problem. I certainly found it to be very difficult to solve, but we've eventually got to a solution. And of course, we'll be doing the JavaScript implementation of this. So as we do with most of our videos, we're going to discuss the problem very quickly. We'll go through an algorithm, we'll look at the code, and then we'll test and execute our code. So without further ado, let's discuss the problem right from codewars.com. Okay, so here we are on codewars.com taking a look at the description for the evaluate mathematical expression problem. And the description's very straightforward. We're going to be given a mathematical expression as a string, and we have to return the result, which is going to be a number. So, for example, our string could be 2 plus 2. The result has to be 4 as a number. The numbers could be whole or decimal numbers. The operators can be or are going to be multiplication, division, addition, and subtraction. Nothing too crazy there. And we have to support parentheses. So if we have parentheses, expressions that have parentheses in them, as well as expressions that have parentheses within parentheses, we have to be able to evaluate that as well. White space, there may or may not be white space between numbers, and the minus sign can definitely throw us for a loop. When we have two minus signs, we have to be able to evaluate that correctly, and it really gets interesting when you see the latter two examples, where you have parentheses sort of in between the expression. That can get very tricky and very difficult to implement. We have some invalid examples below, and the validation, that's definitely something that's a lifesaver for us. We don't have to worry about writing code to sort of validate the expression. We're guaranteed to have an expression that's going to be valid. So that's a little bit of a load off of us. And restricted APIs, no eval or functions are well, they're disabled. So if we actually use those functions within our code, it will be rejected. So I encourage you to take a look at this expression yourself to in greater detail, but I think it's a pretty straightforward problem. So let's go ahead and start with an algorithm for how to solve this. Okay, so let's go over our algorithm. To the left, you see that we have an expression that our code is going to receive and be responsible for evaluating. Actually, there's a little bit of a mistake here. That equals 8 shouldn't be there, but let's go ahead and correct that. That would actually be the expression we'd receive, and the answer would be equal to 8. But let's take a look at the needed functions that we're going to write in order to solve the expression that our code is going to receive. Each of these functions are going to have a specific role in evaluating the expression to the left. The parentheses evaluator, starting with that, is going to look at our expression, and it's going to pull out any expressions that we have, including nested expressions with parentheses in them. And then we'll evaluate those separately. So let's take a look. It's going to, oops, made another mistake here. So it's going to start with the inner parentheses expression, and then it's going to move on to the outer one. So that's going to be the job of the parentheses evaluator, to get uh, the nested sub expressions and any parts of the expression that contains parentheses in them, and evaluate them sort of separately. Now, if we have an expression that does not have any parentheses in it, then the parentheses evaluator won't be called upon. Then we have the reduce expression to the lowest terms functions, or the reducer as I like to call it. And what that's going to do is it's going to take an expression like 2 plus -4, which is of course is equal to -2. It's going to take this here, this plus minus, and it's going to change it to a minus sign. So then we end up with 2 minus 4, which of course is equal to -2. Having expressions this way is a lot simpler to solve, and the reducer can help us do that, especially as we start to see expressions that get really ridiculous like this. It would be great to just take this, then convert these 3 minus signs to just one negative sign, and then convert this plus minus to just a minus sign. And then we have 2 minus 1, which is a piece of cake, easy to solve, 1. Moving on to our next needed function is the expression evaluation. And you see the acronym PEMDAS at the bottom of the screen, at the bottom of the expression, that is. And what we're going to do here is we're just going to look at an expression like a 2 minus 1, or a 2 times 5 divided by 1. And what this expression evaluation function is going to be responsible for is to look at these expressions and understand or tell us which operations should be evaluated first. So going based on our order of operations rule, for 2 minus 1, that's simple. We just do one subtraction. And for our second expression over here, we're going to multiply 2 times 5 first, then we're going to divide it by 1. So it's going to follow that order of operations and order of precedence rules. Now, this expression evaluation does not perform the basic arithmetic. It just simply tells us what should be evaluated. And what it's going to do is call upon this math function, this basic math function. And the basic math function is going to take 2 arguments. One, it's going to take an array of numbers. So in our case of 2 times 5, it will take 2 and 5, and it will take a sign, an operation sign. In this case, it will be a multiplication sign, and it will return the result, which would be 10. And then we would take 10 and 1 and a divide sign, which again would just give us 10. So that's all of the needed functions that we're going to have to write in order to solve some of these more complex expressions that we can expect our code to receive. One thing that we should take note of is that when we evaluate these expressions, we're going to substitute or replace the original expression with the answer. So in our case of 2 plus minus 4 being -2, what we're then going to do is take this -2 and we're going to substitute 2 plus minus 4 with -2. And then we're going to continue on with our expressions. So the next expression would be -2 divided by 2 times -4. And of course we know that the answer to this would be -1 times -4, which is 4. And then we would substitute, it should be +4, I'm sorry. And then we will substitute that with this entire expression, leaving us 4 plus 4 as a string. And then finally we'll get to the answer, which is 8. So now that we have an idea of how to go about this with the functions that we kind of mapped out and want to write code for, let's go ahead and take a look at the code itself. Okay, so let's take a look at our code here. At the very top, you see an expression map, which is just going to be a map of all of the regular expressions that we're going to use throughout our solution. If regular expressions is something that you're a little shaky on, I would suggest a primer from Mozilla or other internet sources because we do use regular expressions heavily throughout this solution. The next thing that you see is a function called calculate, which is required by Code Wars. Code Wars, when we submit our solution, is going to call this function, and it's going to look for that function to return the correct value. Scrolling down here, we see the parentheses evaluator. This is a function that we discussed in our algorithm. Same with the reducer, same with the evaluator, and the very same with do math, except we called it just a basic math function. And we're going to go over all of these in greater detail in just a second. But before we do, let's take a look at this test function here. Some of these test values you may see look awfully similar to or exactly the same as some of the test cases from the Code Wars description. Others are test cases that I ran into from trial and error from when I originally submitted my code to Code Wars to test its validity. And I think these are very good test cases to take a look at to see what's expected of your function, of your calculations. So let's go ahead and start from the very bottom, going to the top up, starting with the do math function. Our do math function is very simple and very straightforward. The first argument is an operation, which can be a minus, a plus, a divide, or a multiplication sign. The second argument is just going to be an array of numbers to which the operation is going to be performed against. So if we have an array of 3 numbers, or nums is an array of 3 numbers, we're going to take a running total or a sum of all of those numbers, and we're going to return that as a string. And you can see on the very last line on 135 that we put a plus sign in front of the total if the total is greater than 0. Now, if you remember, in our algorithm, we're going to substitute expressions that we solve with the actual answer itself. So that's why we want to return these things as strings. And if the total is greater than 0, or if it's less than 0, that is, or if it's equal to 0, then we just leave the total alone. That means it's going to be 0 or some negative number. Okay, so let's take a look at our very next method, our very next function, that is. And that function is our evaluator function. And this is the very first function that we use to make heavy use of regular expressions in. So take a look at the MD operation regex. As you can see, it's using the expression map, the global expression map that we talked about earlier with all of our regular expressions that we're going to use throughout the solution. And it's going to look up using the MD key, which is just short for multiplication division, and it's going to give us back the regular expression you see in the comment to the very right. Now that regular expression is just going to give us back a match of the multiplication sign or the division sign, one of the two. So at the very next line, you see MD operations, or multiply divide operations. And the expression that was passed in, we're going to use that regular expression to match it against. And what we're expecting back is an array of multiplication and division signs in order. So for example, if our expression is 2 times 7 divided by 7, then we're going to get back an array of a multiplication sign and a division sign in the same exact order as the expression. Now, if our MD operations, which is an array of the symbols, the multiplication and division symbols, is defined, which it is, then the very next step is we're going to enter into a loop, and we're going to iterate over that array that has our multiplication and division symbols in order. And the first thing we're going to do is we're going to use the multiplication symbol, going on our example expression of 2 times 7 divided by 7. We're going to take the multiplication symbol and we're going to use our expression map, and we're going to look up a regular expression. And what that regular expression is going to do is it's going to match the 2 times 7 portion of the entire expression. The entire expression being 2 times 7 divided by 7, but we're only going to get back 2 times 7. And in the very next line, we're going to use the MD operation, which is a multiplication sign, remember, and we're going to split the expression that we just found, 2 times 7. We're going to split that expression into numbers of 2 and 7, an array of 2 and 7. The very next line, we're going to take the result. We're going to pass in the numbers array, which is 2 and 7, and the operation, if you remember, is a multiplication sign. And our do math function is going to give us back a result of 14. And then the very next line, we see the expression. The expression is going to be it's going to replace the 2 times 7 portion of the overall expression, which is 2 times 7 divided by 7. It's going to replace the 2 times 7 part with 14. So now the new expression is 14 divided by 7. And we're not done yet, because earlier we had a array of a multiplication and a division sign. So now we're going to go through this process again, but the only difference is that we're going to be doing division, and our expression this time will be 14 divided by 7. Okay, so moving along to the next part of our evaluate function, we see this add subtract or AS regex. And what that's doing is it's searching our global expression map that we talked about earlier to get us back a regular expression that would give us 3 plus 1 if our expression was 3 plus 1 minus 0. So moving along, we see we have a for loop, and the reason we have this loop here is because, very similar to the multiplication and division, we're going to take an expression similar to 3 plus 1 minus 0, and we're going to break it down. So we're going to start with 3 plus 1. Now in the line 101, where you see add subtract operation or AS operation, it's going to get back the plus sign. So out of 3 plus 1, it's going to give us back just the plus sign. So we know what operation that we're doing. Now the AS operation index is just going to give us back the index of the plus sign. So in this case, the index is going to be 1 out of 3 plus 1. The very next lines that we see, we're going to get numbers. Very similar to the multiplication and division, we're going to get back numbers. We're going to get an array of 3, and we're going to get back of 3 and 1. So that's going to be our numbers array. And then, very similar to the multiplication and division problem that we saw above, or code that we saw above, we're going to ask our do math function to perform basic arithmetic, the operation being a plus sign, and the numbers 3 and 1 giving us back a result or sum of 4. And then again, we replace the original expression, which was 3 plus 1 minus 0, with now 4 minus 0, because we want to substitute the 3 plus 1 portion of it with the sum that we just got. And then we go back up to the top and we repeat the same process, but remember, we're going to be doing subtraction this time because our expression is now 4 minus 0. Okay, so let's take an example, a full-scale example of how this evaluation function works from top to bottom. So let's take a look at this expression here in the comments, right by the return statement here. You have 2 plus 7 divided by 7 plus 3 plus 1 minus 1. So the first thing that's going to happen is the multiplication and division will take place. And this is actually wrong. This should be a multiplication sign. So now you have 14 divided by 7 plus 3 plus 1 minus 0. That's your new expression, because remember, we do 2 times 7 first. Then we do 14 divided by 7, which will give us 2. And now our expression would be 2 plus 3 plus 1 minus 0. 2 plus 3 is equal to 5. And then we're stuck with 5 plus 1 minus 0. And then we end up with 5 plus 1, which is 6. And now our expression is 6 minus 0. And then eventually we get the return value of 6. So you can kind of see how the evaluation function takes our order of operations correctly and uses the do math or our basic math function to return the desired result. Okay, moving along to our very next function is our reducer function. And what this function is going to do is take the expression as an argument, and it's going to look for all of the necessary minus and plus signs that we can sort of minimize or reduce. So at the very start of the function, we see two regular expressions, one minus reg x and one plus reg x. Both of them are going to the global expression map to get the regular expression that we're going to need to find all of our minus signs and plus signs within the expression that's passed into us. At the very next line on line 54, you see the expression is going to be replacing all of the spaces with empty spaces. So we're effectively removing all of the spacing. This will help us out tremendously as our expression, we don't have to worry about any spaces in between numbers or signs of any kind within our expression. The very next line, the minus matches, what that's doing is finding all of the minus signs in the expression. It could be singular minus signs. It could be a contiguous block of minus signs. So think of like 3 consecutive minus signs or 4 or 5 or however many. It's going to find them, and then it's going to go through each of the matches that it has, or each of the minus signs that it finds, each minus sign represented as a separate string or maybe a contiguous block of minus signs. It's going to go through them, and it's going to check the length. So if we have let's say a contiguous block of minus signs that's an even number, let's say 4 of them, we're going to replace that block with just a single plus sign. If we have a block of, let's say, 3 consecutive minus signs, what we're then going to do is just replace it with a single minus sign. So that's going to help us out a lot when it comes to our expressions. Now, the plus matches that you see here, it's doing the same thing that we saw above with the minus matches, except that we're looking for plus signs. And it has some of the same logic, except that plus signs are a little bit different since we don't necessarily care whether or not we have an even number of plus signs or a odd number of plus signs. We can always reduce 2 or more consecutive plus signs with just a single plus sign. And now we have special rules for when we have combinations for plus minus and minus plus combinations. We can always just reduce those to a single minus sign. And then we return our reduced expression. If you look at the comment to the right, you'll see an example expression of 11.0 divided by 5 minus signs and positive 4. The way our reducer will work is that it will take that expression and it will reduce it down to 11.0 divided by minus one single minus sign, because remember, we have 5 consecutive minus signs. We reduce that to a single minus sign and we keep the positive 4. Then we reduce it even further by just taking the plus minus combination that we see according to our rules above, and we substitute it with just a single minus sign. So now we have 11.0 divided by minus 4, which is a lot easier to solve than the original expression that was passed in this hypothetical example. Okay, so moving along to our next to final function, which is the parenthesis evaluator. This code can be best explained through an example because it does contain some recursion, and it's very easy to get lost with recursion. So I'm just going to explain what this code is doing from an example. So let's say that our expression that's being passed in as an argument to this function is equal to open parentheses, another open parentheses, 2 times 3, closing it off, and plus 1 plus 1. So we see we have an expression that contains a nested parenthesis expression and an outer parentheses spaced expression. So the very first thing that this code is going to do is it's going to find 2 times 3 in parentheses. And then it's going to evaluate this 2 times 3 in parentheses expression as 2 times 3. And of course, it receives help from the evaluator function that we covered earlier. So this is going to give us 6. Once that happens, once we have an answer for that expression, the original expression is now going to look something like this: 6 plus 1, close parentheses, plus 1. So as you can see, the 2 times 3 in parentheses got substituted with the answer, which is 6. And then we just sort of follow the same logic. So then where we look at 6 plus 1, that's going to be evaluated as just 6 plus 1. That's going to give us 7. And then the expression will then look something like this: 7 plus, no, it's not a 7, 7 plus 1. Now, if you take a look at the very last statement, well, not the last statement, but the if statement, sort of at the end, within the for loop, you see that the evaluator gets called. And at this point, we have 7 plus 1. So the evaluator is going to give us back 8. And then we're going to end up returning that result at some point. So it's a very complicated looking function in a lot of ways, but this is simply what it's doing. So that sort of wraps up the parentheses evaluator. As I mentioned earlier, where we're going to see in a few seconds that we only call upon this parentheses evaluator when we have an expression that contains any parentheses. Now, the reason that I chose to implement this function this way is because honestly, I could not write a regular expression that would be able to go through and group out all of the different nested parentheses expressions. Although I mentioned that regular expressions is used heavily throughout this solution, by no means am I a regular expression expert. So let's move along to our final function above. So moving up to our final function here, the calculate function, which is required by Code Wars. And it is the function that is going to be called by Code Wars to make sure that our code works. And the important thing here to understand is that, like we mentioned earlier, we're just going to run a very simple test to see if an expression contains parentheses by just seeing if it has an open parentheses. Remember, our expressions are valid. We're always going to be given a valid expression. That's what Code Wars said to us when we looked at the description of the problem. So if we see that it has an open parentheses, we assume that it has a parentheses, and we're going to pass it to the parentheses evaluator, which is then going to give us back the value. Otherwise, we just call on our evaluator, sort of straight up call our evaluator. We call the reducer to make sure that we reduce the expression in its simplest form, and then we get the answer in the value variable. And then remember, everything is a string, so then we just go ahead and parse it as a float and return the value. And that should do it for our code at this point, describing everything within our code. I think that the very next thing we should take a look at is the actual test. Let's go down here and look at the test. And as you can see, there's a number of tests here that we're going to run our code against using just making sure that the values sort of are what they are, and to check the validity of our code. So we're going to go ahead and run this just to, we call the test method down here. So we're just going to go ahead and run it and make sure that everything works. So here goes. Okay. Run it right in IntelliJ. Okay, so let's take a look. Well, for starters, we use a search statement. So we know that everything passed, because if it didn't, then it wouldn't have finished and it would have told us, we would have gotten an assertion error. So let's go ahead and start at the very top. We see that we expected 9, we got 9. 0, 2, all the way down. We can just check some of these out very quickly. It looks like for the most part we're getting all of the answers that we were expecting. And there you have it. So I think at this point, we're ready to go ahead and submit our code to Code Wars and have it go through its rigorous testing. And let's find out if our code actually works the way it should. Okay, so here we are on the Code Wars website with our solution in tow. As you can see, the code is exactly the same as the code that we went over. We removed the test cases, obviously, because Code Wars is going to use their own test cases to validate our code. So let's go ahead and test it. All right, let's see, test. Okay, so it looks like it passed. So now we can go ahead and hit attempt. Normally it would say a submit button here to submit the solution, but I've already done the solution prior to the video. So let's just go ahead and attempt to run it against the full test suite. And it looks like it passed. So I don't know why, but it looks like it only passed, or it only ran one test. I'm not sure, but it says it passed all the tests. But I can assure you that there were a lot more test cases that the suite had gone through, and many of those test cases was in the test function that we saw earlier. So that'll do it for this video, or this problem. If you stuck with me this far, because it was a very long video, I really do appreciate it. Even if you managed to skip through the video and get to this point, I really do appreciate it still. If you haven't already, please hit the subscribe button at the bottom and get the notifications whenever I send out a new video. Please like the video as well. And with that being said, with this problem being wrapped up, I will see you guys in the next video.